So let me restart. So today I want to spend the class time and also do some class exercise going over classes and objects. For some of you guys, it is probably a review because you are very comfortable with the classes and objects, but I'm also getting quite a few questions from other students. Again, I think both sections and from both sections where people are asking me questions and they write to me that they're really confused and they cannot get the program to work. So my plan today is to kind of use, and I'm going to write a few things on the board and then I'm going to go back and start writing some code. And then I'm going to go over the upcoming exercise for the class, for the assignment that I have put up. But you guys can get started on it in class, or at least get a few of them done, because some of them are really, really small programs, okay? Now, some of you guys have seen the work and they have submitted work, really good, tells me that you kind of understand it, okay? But I think I'm getting a whole lot of questions from them. Now, another thing that I'm going to add is next week, you're going to have an exam. The first exam is going to go over from chapter 1 through 5, okay? We have covered until 5, and then we'll start on 6. That's what I was planning to do today, but then I said I was getting so many questions. So first of all, take a look at the video that I have posted. It's an outside video, but I found, and I kind of go through and try to research and find out what's a good one, which is simple enough, easy to understand. And I really like the way he did the video. Okay, it's an outside video. It's about 2018, 2019, but I think, really good, great example. So I'm going to start from there. So we talked about classes and objects, and some of you guys even answered some questions about what a class is and what an object is. And a lot of times I found that you did not quite fully, at least even if you understand, you did not reflect it on your answers. You were very brief and not quite explaining the things about classes and objects. So I'm going to kind of flip it and start with objects. So in object-oriented programming, anything that you see could pretty much be described as an object. So you can have a camera, that's an object, a computer is an object, a desk is an object. So anything that you can see can be considered an object. So if I say something like a Honda, a Toyota, and a Chevy, these are all objects. These objects are going to have their own properties. Okay, so they might have a color, a name, and somebody might come back and say, well, my name is Honda. That is okay as well. And there can be other things like vehicle ID number, okay, or VIN number. And then this car, or car 1, and if I want to say, let's do this. So instead of saying Chevy here, I'm going to say car 3, car 2, car 1. Okay, so now I have a color, name, and ID. And I can also have, so these are going to be my instance variables. And then I can also have some methods. And remember, anytime you have a method, you are going to have a parenthesis like this. Okay, so car1, car2, car3, they would all share some common characteristics, right? So everything is going to have a color, name, ID, and of course the same thing with your car2 and same thing with your car3. So now you start looking as, okay, what are some of the common characteristics that I find in every single object? And if you see that there are some common things that goes for every single car, then you might think about creating a class, and that's a little more of a general, and we might call it vehicle. Right? So a class would be a blueprint of similar objects. With me? So these are my individual objects, and some of them have some common stuff. So I'm going to create a class called vehicle, which is going to be the blueprint of everything. Yes?
So car 1, car 2, and car 3 would be all objects in the class vehicle?
Correct.
Okay.
So my vehicle would be my class, and these are going to be my objects. So car 1, car 2, car 3, car 4, I can have as much as I want. Okay. So now if I actually come in and if I look at the characteristics, I can say I'm going to have, remember in Java, I have to say string, and I'm going to have a name. I have another string, and I'm going to call it color. And I have an, let's say, integer, and I'm going to call it VID, vehicle identification. Actually, I should have called it VIN. Let's see. VIN. All right, and then this card again, something that is similar to all cars. You can brake, you can go backward, you can go forward, right? Now I can say brake, and let's say I'm going to say another one called forward. All right. So then I have two methods. One is called brake, and one is called forward. Okay. So this also kind of looks something like an UML diagram. Okay. So this representation of a class is given by this UML, Unified Modeling Language Diagram. Now, if you go back and look at the book, you will see that when they write these things, they also add a few more things. For example, if you call this a private, then I think they call it a negative. If you call this a public, then they add positive. Those are the things that you need to go back and refer back to the book and see how exactly they write things. The break, the methods, depending upon if it is an empty one, if it returns something, it will probably have a colon and write the data type that it is returning. Okay, there are more specifics to it, but I'm kind of coming to a very general description of this, okay? So now, I'm going to delete these things and I'm going to start naming them, okay? Do we have any question up to here? Do we understand a general, or do we have a general idea about classes and objects? And you can come up with anything. So if you say, I gave an example of car 1, car 2, and car 3. What about students? Right? Nicole, Carolina, Jared. These are all students. They all have some similar characteristics. They probably have a name, an ID, a gender, maybe a program. So these are all similar objects. So I can actually define a bigger blueprint called student as a class. That class would then have those characteristics like an ID, a name, a gender, a program. Out of that blueprint, I'm going to create object 1, object 2, object 3, object 4, which are Nicole, Carolina, Jared, Jerry, okay? So I am going to create those things, but all of them, they are similar objects which belongs to the general class. So now, can you think of other things? Absolutely. Students, employees, accounts, vehicle, animal. Well, then you can say, well, what kind of, let's specify, you know, 4-legged animal, right? So think about what else you can have a class and object. So anything that is similar, they're objects, and the blueprint at the top is class. We're good? Okay. Now, let's write it in Java code. Okay. So I would start this with I would start it with, now it is going to be, just trying to fit everything in here. I would not be able to write all the individual syntaxes. When we go back to the code, we'll take a look, but I'm just going to give you some general things. So I said that I'm going to have a private instance variable. Remember, what are these things? They're my instance variable. These are my methods. Okay. So if I call them private string name, and I'm just going to go with 1. Okay. Then similarly, I can define more string color, string or integer ID. Right? So I'm not writing these two things anymore. Now, since I define this as a private, I am going to write some public methods, and generally I write public either, and I'm going to go with just 1 again, get name. Now when I say get, remember I have to take a string out, so I'm going to say public string get name. Let me clean this thing out a little bit. So I'm going to say public, remember it's returning something, string, get name, and then it's going to have a curly brace, and it's going to say return name. Right? Now, I'm also going to have so that's now 3 objects. I'm going to have 2 objects. I'm also going to have public set name and oh, come on. So now I'm saying string name. Now remember, this is my variable that I had defined over here, right? So I want to take the value in when I set my name and then assign it to this, right? So I'm going to say this name then is name equals this dot name. Now, do I have any question over here? So since I took my since I said public void set name, I pass a parameter string name. This is just a variable name. It can be name, it can be n, it can be name1, anything. Whatever I want to set as a name comes through this parameter, and inside the body, I'm going to assign that value that comes in to this instance variable that I defined as private earlier. Do I have any question here?
Can you repeat that?
Okay, so when I create a method called public void set name, the set name method is expecting a string to be passed through. So I just define the data type that is expecting and a variable name, right? Remember, this doesn't have to be exactly the same name. It could be A, it could be N, it could be anything. Yes?
Does it matter if I write this dot name equals to name or name equals to this point name, the
No.
order?
No, the order, because remember, that's why I write this one first, and it's easier if I call it just n. Because what you're doing is, whatever you are passing, whenever you call the set name method, you are supposed to be passing a string. So whatever value you are passing, you're taking that value and assigning it over here. The this only comes in because I have the same name. When I have a different one, then I probably do not need this over here. I say, okay, whatever value I'm passing, I'm just giving a template. I'm giving a variable name. So whatever value I'm passing is now taking that value and then storing it in name.
But can I write n equals name?
No.
No. Okay.
So the question was, what does A equals 5 or 5 equals A? Generally in programming, everything goes from the right to the left. So the way you read this is, this value of 5 is stored in the memory space that I have assigned earlier and called it A. With me? So if this is all in my computer memory, I assign this memory space as A. And when I say A equals 5, it's actually putting a value in. Now, remember, some of these things are referencing, so it's not quite there because that space probably has a memory ID or a memory name, or actually there's a memory value over here, and that is actually referencing to 5. But for right now, just for easy purpose, I'm saying this memory space, we have defined it as an A, is going to store the value 5. Now, in this language, in Java, you have to specify what kind of value you are going to put, not like Python. So when you say A, this is going to give you an error. You have to tell me what kind of value you're going to pass. So that's why I say int A, and then I can put in the value 5. In your computer, if you want to define this as B, but store the value 6.7, then you have to say this is a double or a float. So you have to tell them what kind of value you're going to store, right? You can't just do anything. You cannot do anything. And this is the same thing over here. When I call this method called setName, okay, setName is going to come back to class and say, okay, what does setName allow me to do? It says setName allows me to pass one argument of the type string. So whenever I call my setName, I have to pass in a string. Do I have an understanding of this? Very, very important. We are breaking it down one at a time. Yes.
So it can only handle whole numbers and not.
Correct.
Okay. So,
Int can only handle whole numbers. Now, if you put in a value that's about 25 numbers, 1, 2, 7, 6, 9, can int handle it? No. There's a specific data type called long int. So individual data types even has some specifics. I don't want to get into that. I don't remember it, but I know that if I really have to be that specific, I'm going to pull up the Java library and say, okay, if I want to store a 25-digit number, what should be the best data type I should use? Same thing with double and float. One of them takes more space because it allows you to space, or it allows you to put more values in there. So I believe it is double or float. One of them takes bigger space. Okay, but again, the general idea is, if I want to store the value 6.7, I have to define it as a double or a float. If I want to store the value Jim, Okay, I have to define this as a string and maybe a. No, actually you cannot do a name. Remember, this is a variable name. It doesn't matter. So I'm going to call it a name, but I have to say it's going to store only string. And yes, then I can put in the value Jim. Everybody good with us? All right. So now, delete all this. All right, so I have my public class vehicle. In that class, I have some private variable, and then I have some public method. Okay. So from here, how am I going to create a car? So this is my special syntax for creating a car. I'm going to say vehicle car1 equals new vehicle. So anytime I want to create an object, my keyword is new. So I have to say I want an object called car1 of the type vehicle that I defined in my class equals new. I'm going to create a new one from the same class that I defined earlier, vehicle. So this allows me to instantiate this object. So when I say I want you to create 5 objects out of this, I'm asking you to create car1, car2, car3, car4, car5. Everybody with me? Now, the reason I'm also spending so much time and going over individual line is because in the upcoming assignment and from here on, I want you to write detailed code, detailed comments, almost every line. So as soon as you say class vehicle, you put in a slash and say defining a class. Private string name, defining a variable. Public string get name, defining a method called, defining public method called get name. I want it almost on every line. Okay. So with this statement, I have now created an object. All right. Now remember, the car has name, color, and VIN. So how do I put those values, individual attributes of car1? I'm going to say car1. Remember, I have already created an object called car1. Car1 dot. This is the Java notation. So I'm going to say car1 dot name equals Honda. So now this car has a name, Honda. How do I give it a color? I'm going to say car1 dot color equals red. So now I have a red car. Actually, I called it car underscore one. I should have called it car underscore one. You with me? Because these things matter, right? If you call this object car underscore one, then when you create your object here, you got to give it the same name. You cannot just call it car one and then think that this is what it's referring to. You guys with me? Yes, no? This is your chance to ask me questions.
Can you repeat it?
Okay, so if I call it car underscore one, then when I define my object here, I have to give the object the right name. So I'm going to say vehicle car underscore one equals new vehicle. That's all I'm saying. Right? So now I'm saying car underscore one dot color. So now I have a Honda and a red. Okay? And then if I say car underscore one dot VIN equals 29506. So now this car has a VIN 29506. Do I have an understanding? So this is how I would create an object and assign some of the values. Can you help me create car 2? What do? I say this. I'm going to say vehicle car 2 equals new vehicle. Right? As soon as I do that, I create this object. Before I did this one, this wasn't here. Right? As soon as I said vehicle car 2 equals new vehicle, now this thing got instantiated. Or remember I said giving birth. So now I created my second object called car 2. Now if I want to assign a name, what do I do? How do I do it?
Car underscore 2 dot name equals and then.
Okay.
name you want to give
What do
it.
you want to call it? Chevy?
Sure.
How do I assign a color?
Car underscore 2 color
And we call it blue.
blue.
Okay. How do I create a VIN number? Nico?
Car under 2.
Okay. Object name, car underscore 2, and then,
Then
no, you're missing something. What is you missing?
Dot name.
Dot.
A dot.
oh, dot.
So car underscore 2 dot VIN. All right. So now I say 5946. Okay? Any question here? None? None, right? Now, even though I wrote a method, I did not really define my method, right? So the way I can define my method is by, again, calling the object number dot break, car underscore one dot forward. But we keep on saying Honda red 29506. When I say this car dot name, it gets assigned. But how do we know that it really is assigned? We can call a method, right? Remember this get name and set name, right? So I can also, instead of saying car1 dot name equals Honda, I can say car1 dot name or car1 dot set name and pass Honda. With me? So I'm going to do this. So I can say, let me write this one. Car underscore 2 dot set name Chevy. Now, even though I was telling you about car1 dot name, car1 dot color, car1 dot VIN number, you think it really would work? Actually, it would not. You know why? Because you define these things as private. If I did not define them as private, if I had left it as public, you saw how I said private? If I had changed it to private, all these things would work. But since I defined that as a private, these things are not going to work. Why? Because I call it private. So I cannot put in a value directly by associating that with dot name. I have to go through a public method. So now a public method is car underscore 2 dot set name. And remember what set name is looking for. Set name is looking for a string, right? So as soon as I pass in Chevy, it actually passed in Chevy right through here and assigned it to this variable called name, which I define as private. Yes? How do I get the name back? I said, yes, I did it. I can write a method called getName to return the value. So if I say car underscore 2 dot getName, then it is going to return what? Return name. Now, is it going to show on your screen? If I just say car1 dot getName? No, why not?
Because you have to set it.
You have to either set it to a variable and then write system.out.println, Or you can write system.out.println and then call the method car_2.getName. Everybody with me? Yes? No? This is your chance to ask. If you have any doubts, this is the time to clarify things. So if I want to call this and show it on my screen, I basically have to write this whole system.out.println and then call this method car2.getName, and it's going to return Chevy. System.out.println car2.getColor. It's going to write on the thing saying it's a blue. System.out.println car2. Again, I have not defined, I just did the set name and get name. At this point, I have not defined how to get the color back or the VIN number back. But the process is going to be the same. You have to write get set for every single variable, instance variable that you define. I started showing it to you with the first one. So I can say yes, car2.setName Chevy is good. Car2.getName is going to give me Chevy. Yes? Okay. Now, in all this, I never created a constructor. What are constructors? Constructors special methods. What's the characteristic of a constructor? It always has to have the same name as the class. So do you see any other method there which says class vehicle? You don't see it. But the program still works. Why? Because Java by default produces you with one. So Java gives you one of them and you can use it, which is kind of not shown, but it lets you do it. But you can define your own constructor as well. So let's now define some constructors. All right. So okay, everything is good over here. Okay, I'm going to go to File, New Flip Chart. Okay, so now I'm going to define a class, and I'm going to call it public class vehicle. And then I'm going to say public vehicle. So now here is my first constructor. Okay, this is the one that Java provides you with, but I wrote it on my own. As soon as I write it, it overwrites the one that was given to me. Okay, now you see over here, I need to write that little parenthesis because that tells me that that's a method. Constructors are nothing but special methods. Okay, now how do I know it's a constructor? Because it has the same name as this. Also, constructor, you never say a return. You know, it doesn't specify that it's a string that it's going to return or any of this. It just has the same name. Okay. Now, I can also write another constructor, and in this case, I'm going to write public. Actually, let me back on just a little bit. So remember, in my public class vehicle, I had defined some private string name. I also created private string color, and I also did private int red. Okay. Now I say public vehicle. So this is my first constructor. Okay. I can also have another constructor. And I'm going to say in this one, if I call this constructor, then I have to pass in two arguments. One is a string value, one is an integer value. Okay, so then I have to say, okay, the value that I'm actually getting from here equals this dot name, which is this one right here. So right, do you know what I mean? So the name that I am going to take in by using that signature is now going to be assigned to that instance variable that I had defined as my class. Now, generally, when you go back to the concept of memory allocation, when you have something like this public class vehicle and all these things done, there's really no memory assigned to it. The memory only starts getting assigned once you start creating the objects. That's really one way of allocating or managing the memory in Java. So when you write all these things, nothing has been taken. You're just telling them, okay, I'm setting it all up. But as soon as I start creating my objects, that's when it says, okay, now I'm going to create some memory and I'm going to store my own information. Remember, my class was my blueprint, right? So I have this one, which takes 2. I can write another one called public vehicle int ID string name string color. And then inside the body of this one, I can even say this ID equals Vin, this name equals this name, so I'll have to say this dot name and color. Color this dot color. Yes.
So for Vin, would it be this dot Vin as well, or is Vin
No,
equals ID?
it's not Vin because I created a separate variable name. So that's why I don't need this. This is just more of an implicit reference.
Okay.
So the reason we use this is because if I have the same name as a variable that I'm passing and also as an instance or a private variable, that's why I want to say, okay, when I take the value, it is actually stored in name that is called this name. Okay, so that's why you do not need a this. So that's why I was kind of giving you some color code. So if I'm saying color, oops, this color is the coming from here. So this is this color, which is now assigned to, if I come back to this one, is actually assigned to this color. Same thing, my name is going to that orange name. So now I created 3 overloaded constructors. How are they different? Their signature is different. What do we mean by signature? One of them does not take any arguments. The other one takes 2 and the other one takes 3. Do we have any question here? So I created 3 constructors. These are called overloaded constructors. Why is it overloaded? Because they have the same name. But to the Java compiler, when you use them, it knows how to differentiate between them by looking at the signature. We good? All right. Now, no question on this part of constructors, right? So now I'm going to create objects. So then I go to a separate file. I said public class vehicle test, right? Then I go write public void main string argument, because remember you have to have that main method and then you start the body. And how do you create objects? Somebody help me out. What do I call? How do I create objects? Vehicle. Okay.
A name,
Okay. What do you want to call it?
vehicle 1,
Car 1
harm,
equals
new,
Would it be car_1 or just car1?
well, in the other one I had already defined the object. Over here I did not, so I just started off with car 1.
Okay.
Remember, they are not set. I mean, it could be the same code, but I'm kind of keeping them separate, just going part by part. So in this case, I just say car 1 because I did not do anything yet. So I just came up with an object name called car 1. Now, you see when you say new vehicle and you see this, which signature from these 3 do you think it's going to use to create the object called car 1? So you have signature 1, signature 2, and signature 3. So when you create an object called car1 and do this, which of these 3 signatures do you think it's going to call for? Number 1. Right? Now, if I say something like vehicle car2 equals new vehicle and then pass if I create an object like this, which is called car2, which signature do you think it's going to call for?
The third one.
The third one. Why? Look at the arguments that I passed. So now this is going to create a Toyota, and it is going to be called right. Now you see this one, the car one, it doesn't have a name, an ID, or a color yet, because my signature does not call me for that. If I want to put some color there, I have to say car1 dot set name, car1 dot set color. Remember those public methods that I had defined? So you have to use those public methods to put values in. And if you want to extract the values out, you're going to say car1 dot get name, car1 dot get ID, car1 dot get color. All right. Now, can you go back and create another object with the second signature?
Yeah.
Sure. So the only thing you got to remember is when you create the one with the second signature, it takes 2 arguments, right? One has to be a string and the other one has to be an ID, an integer. Are we good? All right. So now, we'll get rid of all this thing and come in to this and for those of you guys who are outside, you probably cannot hear it unless you
Hey guys, this is part 1 of my introduction to classes and objects. And in this video, I'm going to talk about what are classes and objects, and then what are attributes, methods, and constructors. And at the end of this video, I'm going to give you some code samples in Java, but this video is going to be mostly language independent, so you'll be able to use what you learned in this video in whatever language you're using. Classes and objects are actually one of the most fundamental topics when it comes to data structures and algorithms. So let's get started. So what are classes and objects? I think the best way to explain what they are would be to give you a really concrete example. So let's say as an example,
Recording.